Hey scholars, so today we're going to talk about percent increase and decrease. So later next week, we're going to start talking about specific kinds of increase and decrease, but this is just going to be kind of a generic, does it increase, does it decrease? We'll see a lot of these questions with like population on our state test. So it's like the population of this city was this, now it's this, what was the increase or decrease? So things like that. The issue with percent increase decrease are there are lots of different ways we could have these problems. It could be find the percent increase or decrease, or it could be like, okay, so it was this, here's the increase and decrease, what is it now? Or it could say it's now this, it increased or decreased by this percent, what was it originally? So how the same way we had 3 different ways for quantity equals percent times whole problems, where there's the 3 different ways, either the quantity was missing or the percent was missing or the whole was missing. We're going to have those with percent increase and decrease, but we're also going to have those in a way where we could have it. So it's an increase where it went up or a decrease where it went down. So it's almost like there's 6 different variations, but I promise it's not going to be that bad. There's just a couple of key things for us to keep in mind. So our objective today is that we can solve percent problems with an increase or a decrease. So let's look at our review question because that's something we already learned. It's usually based on our last lesson. So Devin is a real estate agent. He makes 5.25% commission on any house he sells. Devin sells Miss Marnon a house for $149,000. What is Devin's commission? So if you need help, you can go back to our page 10 notes, but pause the video and see if you can do this review question on your own. Okay, so you should have been able to do this one. This is just a quantity equals percent times whole basic commission problem. So when we're doing quantity equals percent times whole for commission, we're always trying to figure out that quantity. What is the commission? And right here we have our percent is 5.25% times the selling price, which was $149,000. We need to just change this percent to a decimal. This is 0.0525, making sure we have that extra 0 because this would be the 500ths. So it's in the 500ths spot. If you put it right here, that's tenths times 149,000. So we can just type this on our calculator. We get 7,822.5, so that's 50 cents. So 7,822.5, and because it's money, I'm going to put the 0, so it says 50 cents. So that is Devin's commission. Our preview question, the cost of The Last of Us Part 2 was selling for $60. The price has been reduced to $30. How much was the price reduced? So this shouldn't take us long to answer. Pause the video and answer it really quick. Okay, so the price was reduced. If you did 60 minus 30 to figure out what that difference is reduced $30. So in half. Some quick vocabulary, just to make sure. Increase is go up. Decrease is go down. So anytime I see the word increase, I like to box it and put an arrow with an up going on it. And if I see the word decrease, I box it and I do an arrow going down. So let's start looking at some of our notes. So this first one, Mounby likes jewelry. She has 5 rings in her jewelry box. Sketch her rings. So pause the video. Just sketch her 5 rings. They can have as little or as much detail as you want. Okay, I'm just going to draw 5 circles. 1, 2, 3, 4, 5. Those are her 5 rings. So now it wants us to draw a double number line diagram relating the number of rings to percent of the whole set. So I'm going to have this line on top be the rings, and this line on bottom be the percent. So if I have 0 rings, it's 0%. So right now she has 5. So I'm going to put 5 rings on here. That's her whole set of rings. We've said a whole is always 100%. So there's our double number line, but we need to figure out for each ring. So I'm going to break this up into 5 as much as I can, evenly spaced. 1, 2, 3, 4, 5. That's pretty evenly spaced. Good job, Miss Marnon. Okay, so part C, what percent is represented by the whole collection of rings? So the whole is always 100%. What percent of the collection does each ring represent? So we have our 5 rings here as 100% on our double number line. We need to figure out what percent is at each of these. So it's kind of like a tape diagram where you need to split it up. So we have 5 sections here, right? So just let's use the highlighter so I'll mark it. So here's section 1, 2, 3, 4, 5. So to figure out what each percent that is, we need to do the 100 split into 5, and split is division. So that means each section is going to be 20%. So this is 0, 20, add another 20, 40, 60, 80, and then add another 20 gets us back to 100. So each ring is 20%. Mounby's aunt bought her another ring for her birthday. What will be the percent increase in Mounby's collection? So if we get a 6th ring, how much does that go up to? How much percent did we add on? Well, if each ring is 20%, the increase is 20%. We just added another ring at the end. So now it's up to 120%, but this increase, how much it went up, was 20%. So that's just kind of how we can think about it if we need a double number line diagram at all. But let's look at this next question. So Jack increased his Pokemon card collection. So increased, went up by 5 cards. He originally had 15 cards. What is his percent increase? So when we're doing these problems, I always want to come back to quantity equals percent times whole. In this case, our whole is our original. When we are doing percent increase and decrease, our whole is always our original, and our quantity is usually going to be the new or that amount of increase or decrease. And when I say amount, we know that quantity and whole have the same units. So if we're talking about cards, the whole's cards, the quantity's cards, the percent is always the one that's the percent. So I'm going to give myself a little bit more room to write here. So if we're going to do quantity equals percent times whole, he increased it by 5 cards. That's going to be our quantity. We're trying to find the percent. That's going to be my mystery X. But we know that the whole originally he had 15. So if you can solve this one-step equation on your own, pause the video now and solve this equation. Okay, so to solve this, we need to do the opposite of times, which is divide. So I'm going to divide by 15. If I do it to one side, I need to do it to the other side. 15 divided by 15 is just 1, and 1 times x leaves us with x on the right side of the equal sign. 5 divided by 15 is 0.3 repeating. It's 1/3. This isn't a percent though, this is a decimal. So we need to convert this decimal to a percent. It's 33.3 repeating percent. So his percent increase was an entire third, right? And if we think about it, 5 is a third of 15. 1/3 as percent is 33.3 repeating percent. This answer makes sense. So part B, instead of adding 5 cards, what if Jack added just 1 card? Will his percent increase be the same as Mounby's in exercise 1? So Mounby's was 20%, right? So if we just do 1 card, is it going to be the same? So if we're not sure, if we can't answer right away, let's just do the math. So if he increased it by 1 card, let's set up our quantity equals percent times whole. So if our increase was 1 card, let's see, we don't know the percent. We do know the whole is still 15. So we can solve this for x just like before. We're going to divide by 15 on both sides. And we're going to get x is, let's see, what's 1 divided by 15? 0.06 repeating. Let's multiply that by 100 in order to get our percent. So 6.6 repeating percent. So when we think about this, why might this not work? We can go back to kind of think about that question with Keandra measuring the board when we did percent error on Tuesday with page 9. We did percent error. We said we couldn't tell how far off she was without knowing what that original is. So Jack's percent increase was not the same. They both went up by 1, but because Mounby had fewer things, each one was worth more of a percent. So there's a couple of different ways we can phrase this. So we can say it is not the same. So Jack's percent increase would not be the same as Mounby's. So you can reference your work explicitly or you can reason it out. So we can say in my work, I found out Jack's percent increase would be, it's 6.3% or 6.6 repeating percent. And we can say how it's different than Mounby's, and then you could write about how they're starting with different numbers. You can say they have different percent increases because they are starting with different wholes. So you don't need to phrase this exactly like me. There's a million different ways you could say it. You could only say just on your work, or you could just reason it out, as long as you have some kind of explanation and reasoning. So let's look at our last exercise together. The population of stray cats in Syracuse has declined. Decline is another way to say decrease. The past year by roughly 30%. The current cat population in the neighborhood is estimated to be 12. How many cats were there originally? So this is the one where they're not telling us what it was originally. We need to find it originally. So we're going to do this percent problem, this percent decrease. We need quantity equals percent times whole. Now here's the weird thing. So we do know that it is currently 12. That's our quantity because our whole is always the original, and it's not originally 12, it's now 12. But we got to think the percent here, this time it's not 30. It went down by 30%. If you think about having a whole as 100%, and then you went down 30, you got rid of 30%. What this 12 really represents is 70% of that original. So when we're using this quantity of 12, does this 12 represent 30%? Or does it represent a different percent? And in this case, because we went down 30, the 12 doesn't represent the 30. It represents how much it actually was. It's the 70. So these are going to be what are the tricky kind of percent and increase and decrease problems, because sometimes they don't give you the value for the quantity that was the increase or decrease. So like here, the increase for Jack's cards when he added 5 was 33.3%. If they told you that it increased by 33.3% and now he has 20 cards, you're going to have to use a different percent. You're going to have to use 133.3% because it's that 100% plus that 33.3%. So it's going to be a little weird, and if you have trouble with this exercise, please make sure you are talking to your math teacher about it. whether that's me, Miss Reno, whoever. This is kind of the trickier kinds that we'll see is finding the whole, because the quantity they're giving us is not always going to be how much it actually went up or down. So we're going to actually use 70% in this problem times our mystery whole. So if you can solve this from this point, pause the video and solve this on your own. Okay, so I'm going to just rewrite this 70% as 0.7 times x. We can now solve this one-step equation because it's multiplying. We're going to divide. We're going to divide by that 0.7 on both sides. This will get us x alone on this side and 12 divided by 0.7. I got 17.1428 da 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 da. We're going to say 17.14%. Well, we're doing how many cats there were. Well, let's round it to the nearest whole. Let's say 17 because you can't have 0.14 of a cat. So 17.14 da da da, which is really 17 cats originally. Now, if you didn't know to do that 70% thing where we had to subtract it from 100 because it was a decline of 30%, what you can think about is if you did this with 30%, did the number make sense? The other thing is anytime you get a number that doesn't make sense, so if we're talking about originally and it declined, that means we're going to have more. So if you got a number that was smaller, something went wrong. So always checking to make sure your answer makes sense in context. So if we're talking about before there were more cats, yes, 17 is more than 12. So just kind of making sure that our answers make sense in context, but definitely if you don't understand this exercise 3, reach out to your teacher so they can help you. So we're just going to kind of reiterate what this quantity equals percent times whole is in an increase or decrease situation. So the quantity is usually going to be the amount of the increase or decrease. And let's do this like a bit. The percent is always going to be the actual percent increase or decrease. And then the whole is going to be the original or the starting point. But there are some other things that this could also be. Like we just saw in the last one, sometimes it's a little bit different. So let's write this in a different color so we can see. So sometimes the quantity is the new price or the new amount, right? And when they give us the new amount, our percent that we're going to actually use is not going to be the percent in the problem. It's going to be 100 minus or 100 plus. So you need to figure out what percent the new amount is of the original. So that's going to either be 100 plus or 100 minus, depending on if it's an increase or a decrease. So if it's an increase, it's 100 plus the given percent. If it's a decrease, it's 100 minus the given percent. So this one in light blue is exactly like what we just did in number 3. So here we did 100 minus the 30, right? And then our whole is going to be the same and normally as it's going to be our original or our start. Whatever that starting amount is or the original. So that was the 17 cats originally. In the new year we had 12 cats. We had to do that 100 minus. So still it's quantity equals percent times whole. We just got to kind of think more about how our percent and our quantity and our whole are related. So now you have practice problems. There are 3 practice problems. If you need more help with ones like this exercise 3, definitely try out this number 3 in the practice as one of your choices. So you're going to pick 2 of these And then you have your exit ticket about Miss Torres's car payment. So you might remember in the commission one that she wanted a mom car. Owen convinced her to get a fancy sports car. So now her car payment went up. So now instead of $240 a month, she pays $275 a month. So figure out what was her percent increase. When you're done with this, you have an independent practice 22. Now you might get questions that are like the easier percent increase. What's the percent? But you also might get questions that are more like this exercise 3. So if you do have problems with those, again, make sure you're talking to your teacher. But when you're done with your independent practice 22, you're all done with this lesson on percent increase and decrease, and we'll start talking about markups and markdowns next week.